Isn't this the most beautiful thing you've ever seen? Who knew learning about gradient could be so beautiful? I am Astrid Nalvita, the Maths Mentor, here to help you pass your next maths exam. In the last video on the calculus playlist, I covered how to find the gradient between 2 points. But what if no points were given? You find your own points. Look at this. We have a beautiful heart-shaped graph here, and we are asked to find the gradient at point E. First of all, we need a tangent, so let's draw one in. There we go. Remember, a tangent is just a straight line that touches only one point on the curve. Now that we have a straight line, we can find 2 points that we like the look of and find the gradient. So along here, I like the look of this point here because it's right at the junction of 1.41, and I also like this point here, which is at the junction of 0.6, negative 0.4. Now that you have your 2 points, you can figure out your rise and your run. So the rise from negative 0.4 to 1 would be a 1.4 rise, and the run from 0.6 to 1.4, that's a 0.8 run. And there you go, the gradient would be rise over run. Let's put it in an equation so we can see it better. Here we have the gradient is equal to rise over run. To get the rise, we get the y value of the point on the right, which is 1, minus the y value of the point on the left, which is negative 0.4. And we get our 1.4. To get the run, it's the x value of the point on the right, which is 1.4, and then minus the x value of the point on the left, which is 0.6, and we get our 0.8. And 1.4 divided by 0.8 is 1.75, and this is our gradient. So let's have a think about this. Do we expect a positive gradient? Yes, we do, because we're walking uphill from left to right, and the slope is quite steep, so a positive 1.75 do make sense. Now let's find out what the gradient really is. Let me just turn on the gradient tool. Gradient is 1.75. We got it. Perfect. Bye-bye, beautiful graph. Another situation you could find yourself in is if you were given a straight line formula and told to find the gradient. I'm going to show you 2 ways of doing this. The first way is that you can find 2 points by substituting 2 x values and find their corresponding y values. What do I mean by this? I will show you. Let's substitute an x value of 0 and find what the y value is. So when x is 0, y is 4. That is our first point. I always like to plot the point on the number plane just so I can see where it is. So there you go, 0, 4. Now, with just 1 point, we can't find the gradient. We need another point. So let's substitute in another x value. This time, let's substitute x is 1. When x is 1, y is 10 over 3. Again, I would always plot those points on the number plane. This point is 1 and 3 1/3. So I've plot in my point 1 and 3 1/3. The reason I always plot these points is so that I can use my common sense to see what kind of gradients I'm expecting. So walking from left to right, I'm expecting a negative gradient. The line would not be that steep either, so I would guess the number would be less than 1. So it would be a negative, and then the number is something less than 1. Let's find out what it actually is. So again, we use our gradient is rise over run. To get the rise, you get y2, which is the y value that's on the right point, which is 10 over 3, minus y1, which is the y value of the left point, which in this case is 4. To get the run, you get the x value of the right point, which in this case is 1, minus the x value that's on the left point, which is 0. So you get negative 2/3 by minusing 10 over 3 minus 4, over 1, and that is just negative 2/3. Now, does it make sense to have a gradient of negative 2/3 for this? And I think it does, because I was expecting a negative gradient, and I was expecting the number to be less than 1, which it is. So I'm pretty confident with that. Another way that you can find the gradient of a straight line formula is if you rearrange it into the gradient intercept form. The gradient intercept form looks like this: y equals mx plus b. It's called the gradient intercept form because it has the gradient m and the y-intercept b. So if we can rearrange this equation to look like this one, we would be able to spot the gradient. Let's rearrange it. Firstly, I added 12 to both sides of the equation, and then I minus 2x on both sides, so we have 3y equals minus 2x plus 12. Then I divide it by 3 on both sides, so I have y is equal to negative 2/3 x plus 4. Now that it's in the gradient intercept form, we can see the gradient is negative 2/3, and if you remember what we found before, we also found that the gradient is negative 2/3. Now that's perfect because a line will have the same gradient no matter which way you find the gradient. So whether you would want to find 2 points and then use the gradient formula to find it, or you would like to rearrange the equation to find it, it shouldn't matter. You should get the same gradient. I have included for you a free checklist in the description below to help you pass your next maths exam. Comment below if you know another way of finding the gradient of a straight line. Indeed, there is another way. The next video that I will be covering is the gradient of a vertical line. Try and figure that out before the next video starts.